So here we're given this frequency chart and we're asked to find the standard deviation of all these scores. So I'll start with statement 1, says k is 5. So we'll know these values, and even though you don't have to actually compute it, I'll just do that to kind of illustrate the process. So 3, 5, and 7. And we don't know what n is. So the first thing is we can't really find the average. The average will be, the weighted average will be 1 times the frequency plus 3 times 4. Because what this really means is I have 4 values that are 3. And then 8 times 5, n times 7. And then divided by the total number of terms, which will be 13 plus n. So I can't even find the average if I don't know this frequency. K doesn't really tell me anything. And then I won't be able to find the deviations from these scores because it really depends on n. So 1 alone is insufficient. If we look at 2, now we know the frequency. And then the question is, we'll be able to find the deviations from the average. So here, first thing I can do is to find the weighted average. So that would be multiplied by the frequency, these values. So k minus 4 plus 4 times k minus 2 plus 8k plus 12k plus 24. And then I divide by the total number, which is 25. So in the top, plus 4k minus 4 plus, this becomes 20k plus 24. And then that minus 8, I subtract that, that becomes 60. And then I have 25k plus 16 over 25. And this will become k plus 16 over 25. So the key thing is this k term comes out separately. That means these deviations, and let me just do that for k minus 4. If you were finding deviations from the average, would be this difference. And you'll see the k term drops out. You don't have to worry about what numbers are left, but that's the deviation. Same thing will happen with that. We'll get a number, a numerical value. So the deviations from the average, which is this, will be independent of k. And so to find the standard deviation, we'll be squaring the deviations of all of these. And of course, we have to weight them by how many there are. And so we'll be squaring those deviations and then dividing by the total number, which is also fixed, which is 25. So these are all going to be numbers. So that means we have a unique value. And statement 2 alone is sufficient. And it doesn't matter what k is because the deviation is independent of k. So the answer is choice B.